Okay, young adults, this is Mr. Picard, your well-rounded math teacher, and we are going to be working on Unit 2, Video 3, basically notes, Unit 2, Notes, Video 3. Learning targets. We're going to construct and analyze scatter plots, and we're going to do line of best fit for data in a scatter plot, and then do predictions for those lines of best fit. So basically what we're going to be doing is this. Yes, we're working with scatter plots, but it's one of the main ideas in algebra. We need to learn how to make predictions, and we're going to use scatter plots to make predictions. In algebra, we can find patterns and relationships in data, generalize these patterns, and use data to make predictions in future events. We're going to use prior knowledge of slope and linear equations. We want to, in slope-intercept form, y equals mx plus b, but to start out with, we'll put it in point slope form, y minus y sub 1 equals m times x minus x sub 1, and then work it into slope-intercept form. And once we get it into slope-intercept form, we're going to predict future with very good accuracy. Okay, so here's some data. All states in the District of Columbia have enacted laws setting 21 as the minimum drinking age. Basically this table shows how many lives are saved per year because the drinking age is 21. You can see the table is, the graph, the scatter plot is started over here. They have year on the x-axis and lives in thousands saved on the y-axis. And the reason is this. The number of lives saved depends on what year it is. So this is my independent variable, or y. The year is your independent variable, so that's why it's on the x-axis. Okay, so let's get started. First, number one, we're going to graph this information. Well, I'm going to plug it in here. 19.1 is right about there. 2000. 20,000 lives are saved. 2001, 21,000. 2002, 21.9. And 2003 is 22.8. If you want to hit pause and do this quick, that's fine. Now that data there is pretty linear, so it works out well for us. It says draw a line of best fit. I'm going to throw a line in here. And when I bring this line over, does it best match the data? No. You got the 2 points on the right below it and the 2 points to the left above it. This is kind of out of order here. What a lot of people do, hold on here, let me get this back. What a lot of people do is go right through the origin. They always think they have to go through the origin. Well, if I go through the origin, it's not going to best match this data. So I'm going to bring this up a little bit, bring this down a little bit, and try and get it to work for us. I think that line right there is just fine. It goes through all the points. You're not going to have this very often. A lot of points, there will be points above it and below it, but you want to best match the data. You'll see some other linear equations and scatter plots here in a little bit. So this is called our line of best fit right here. Just drawing a line through it. Now, the next thing we want to do, well, it says describe the correlation. What correlation means is this. Well, according to my data, as I go to the right on years, as years get larger and larger, what happens to the number of lives saved? Well, that goes up. This is considered a positive correlation. If you look at this line, the slope of this line should be positive. Okay, so that's my correlation. It's positive. Write a prediction equation for the graph. Well, that's where we get into this. Y minus y sub 1 equals m times x minus x sub 1. Okay. So we need a couple points. Now, all the points of data are points on this line, so I could pick any two and I could have a pretty good linear equation. A lot of times I say, hey, pick the smallest year and the largest year and find your slope that way and use those points to find your prediction equation, or in this case, your linear equation. But just to show that I'm going to pick this point because it's on the line and this point because it's on the line, 1999 and 19.1. That's 1 point I'm going to use. I'm going to use 2002 and 21.9. Okay, those 2 points. Now all I'm going to do is I usually just pick the first point and plug that in for y sub 1 and x sub 1. But we do need the slope here. Well, slope is change in y over change in x. So what do we got? 21.9. That's my first y or second y value minus 19.1 all over the x's now 2002 and 1999. Need a calculator for the top one. Bottom one is 3. If I use my calculator on the top, I think I get 2.8. Okay, now when we're working with these real world problems, when we're actually working with data, you know what I'm saying? You are going to want your slope as a decimal. So take 2.3 and divide it by, 2.8 and divide it by 3, and let's change this to a decimal. And it is 0.93. So there's my slope. I'm probably going to use this first point. Now I can plug it into my point slope form and start actually writing my prediction equation. So let's take this down here and let's start plugging some things in. Bring this back down a little bit, right about there. That's good. Oh. So y minus y sub 1, 19.1. Equals m. My slope is 0.93. We had to find that. And x minus my x sub 1 is 1999. Okay, using the distributive property here. Y minus 19.1 equals 0.93 x minus 0.93 times 1999. Well, let's pull up our calculator here. So 0.93 times 1999. Enter. And we get this. 1859.07. And it's negative because it's a positive times this negative because you're subtracting it. Next step is solve for y. So I'm going to add 19.1 to both sides. And I'm going to get y equals 0.93x minus, because I have more negative than positive. We've got to be careful when we plug this in. We have to use the negative button down here. Negative 1859.07 plus 19.1. So we end up with 1839, negative 1839.97. And that is our prediction equation. Okay? The next thing that they wanted us to do is then make a prediction. E, let's bring E down here, over here, right below it. Bring our calculator up so we can work with that. This is our prediction equation. This is what we got from our line of best fit because we picked 2 points on our line of best fit. It says use your prediction equation to find the number of lives saved for the year 2015. Year is X, so I'm going to plug it in for X right there. Y equals 0.93 times X, but that's 2015 now, minus 1839.97. So how many lives did we save in 2015? Well, plug it all in. 0.93 times 2015 plus, let's go back here, minus, I almost screwed that up, 1,839.97. Enter. And that's 33.98. I think we can round that to 34. So in 2015, we'd save 34 lives. No, it's per 1,000 on your table if you look at it. So we actually save, our answer is 34, but multiplying it by 1,000, it's 34,000. So there we go. That's prediction equations, writing prediction equations, and then actually making predictions with those given prediction equations. Okay. Let's move on to the next one. Scatter plots, correlations. We talked about that a little bit. You can see all these points are kind of going up in a straight line here. This line, however, right here, best fits all the data. That's a positive correlation. Here's a negative correlation right here. The data's kind of going down. An example like that would be the value of a car. When you buy that car brand new, it's going to have a price up here, but every year after that, the price kind of goes down. So that's so as the years increase, your value decreases. That's a negative correlation. And this, if you had data like this would be pretty hard to do anything because there's no correlation there. You can't really draw a line through it. Line of best fit, best matches data, the data that's given. Prediction equation. When you find your prediction equations, you're going to pick 2 points. Pick 2 points on your line of best fit. And then write a linear equation. And that's your prediction equation. You can use that line to make predictions. Now, if you have a table here and your points are kind of all over the place and your line's going through like this, like here, there's only one point that's really on the line. Well, then you got to kind of hopefully match up. Like if this is 1 and this is 3, I could use the point 1, 3, and whatever this point is, to write this prediction equation. So look for points on the line itself, yes, but then also look where it crosses the grid nicely. You want a good point where it crosses the grid if you don't actually have a data point on that line when you're writing your linear equation. So here's another one. Table shows the amount of time 5 different students studied for their AP Euro exam and the grades each one of them received. Make a scatter plot. Okay. The question is, do the grades depend on the hours studied or does the hours studied depend on the grades? Well, grades is your dependent variable. Your grades depend on the time over here. So this would be your y. Y is always your dependent variable. Hours studied, it's time again. That's my independent variable. That's going to be x. You want to spread it out on the graph as best you can. We're going from, looks like my smallest h or x value here is 1, largest is 12. 1, 2, 3, 4, 5, 6, 7, 8. It only goes 8, so I'll go every 2. So down here I'm going to put hours. Hours on the x-axis. So 2, 4, 6, 8, 10, 12, and 14. So, and you want to spread your data out as much as you can. I would have went by 1s if this went out to 12, but it doesn't go out to 12. I guess for a grade on the exam, it goes all the way up to 98, which is almost 100. I'd maybe start out at 70, 75, I think this will work, 80, 85, 90, 95, and finally 100. And then go ahead and graph your data. 580 would be right about here. 995, right about here. 375, right about here. 1298, Can't get over 100%, and then 170. So I would say this correlation is definitely positive. If I'm going to put a line of best fit in there, I'm going to somehow match that data. Let me throw a line of best fit in there. See if I can get in there nice and easy. Well, that's pretty close. I'd pick 2 points on there. I could pick probably any one of these 3 data points here, or I could pick where it crosses the grid nicely here. 10 and 95, this point right here, I could definitely use that. And then I don't know, this second red one is 375. So I could use those 2 points to find slope, plug them into point slope form, and do it by hand. I want you to definitely be able to do that. But with this problem, I'm also going to show you how to use your graphing calculator. So get your TI-84 out. I'm going to show you how to plug the data in and come up with your line of best fit. Okay? So, what do we got here? I'm going to hit clear first of all. And we're working with data and statistics here, so you're going to hit the stat button there. We just hit the stat button. We want to plug in data and then analyze that data, find our slope and y-intercept, and write our linear equations. So we are going to go to edit, stat, and then edit. And edit's highlighted already, so I hit it. L1 is column 1 and L2 is column 2. L1 is basically my x values and L2 is basically my y values. So we're going to plug this data in. There's already data in these columns, so I want to clear out the data. So arrow up and hit clear. When I hit clear and then enter, it clears it out so I can put that data in. So I'll go over here and do the same thing. Hit clear, arrow up to L1, hit clear, and then enter. And back over here. So now I'm going to enter in all my data. You can do it any way you want. I put 5 and then enter. You can go over and put 80 in for the y, but I'm just going to put all my x's in and all my y's in and make sure they line up. So 5, 9, enter, 3, 12, and 1. Go over here and enter all my y data. That's 80, 95, what do we got? 75, 75 goes with 3, yep. 98 goes with 12, and finally 70 goes with 1. So there's my data. It says L2 6 down here. That just means the 6 piece of data. We only have 5 for each one of them. So now I got my data entered. Now I can come up with my linear equation. So now I'm going to hit stat again. I'm going to move this over here because we're going to be filling in some stuff here. And now I want to calculate. I want to calculate this data. It's 2 variable stats, but I'm not going to hit 2 variable stats at number 2. I'm going to go down to lin regression. Linear regression, this is a linear equation. You can see the ax plus b, that's like mx plus b. That's what we want. So we go down to line of regression or prediction equation. They are basically the same thing. And I'm going to hit enter. It says my x list is L1, yes. I'm going to hit enter. Y list is L2, yes, I'm going to hit enter. And now I'm going to go down to calculate and hit enter. Now it's a little bit weird because it says y equals ax plus b. It should be y equals mx plus b. A is basically just your slope. So when I ask for slope over here, I'm going to say I know what my slope is. It's 2.725. We'll just put 2.7. That's fine. And my y-intercept, well, that's your b, is 67.25. So equation for regression line or prediction equation. Regression line and prediction equation are the same thing. So you just write this. What you know your slope, you know your y-intercept, so plug them in. Y equals 2.7. I guess I'll go 2.5 there. Plus 67 point. Get you out of the way here a little bit. 67.25. Good. So you can do it very easily with your graphing calculator. Now it says this. It says predict what score a student who studied 10 hours for an exam would receive. Well, this 10 hours is our independent variable x. So I'm going to plug it in for, oops, I forgot my little x right here. I'm going to plug it in for x right here in our linear equation. So y equals 2.725x, but now x is 10, plus 67.25. Well, I need my calculator here. Plug all that stuff in. 2.725 parentheses 10 plus 67.25, and then just hit enter. Looks like they'd get a 94 if they studied 10 hours. They'd get a 94 or 94.5% on their test. So you might have to watch this again to understand how to use your graphing calculator to write these, or prediction equations or linear regressions. It's the same thing. So I'll just you can just hit pause and rewind, whatever you got to do, and try it again. Okay. What do we want to do now? I want to go to the last problem. Here it is, right here. Okay. This is on Mr. Picard's most recent Algebra 2 test. His students earned the following scores. So there's my scores. I think there's 2, 4, 6, 8, 10, 12, 20 scores altogether. Yeah, 20 scores altogether. Calculate the following. The mean, well, that's when you add them all up and divide by the number of tests. Well, that'd be 20. Median is when you list them in order and find the one in the middle. Q1 and Q3 is when we get into box and whisker plots. You need your Q1, Q3, minimum, maximum, and your median. Well, you can do all of this on your graphing calculator. So I'm going to show you how to do all of this on your graphing calculator right now. First of all, so this is one variable stats, and it's just one thing that you're working with, test scores. You got to plug it in, so we're going to hit stat first again. We're going to hit edit. You can see I have all my old data in here from that last problem, so we're going to arrow up and hit clear, enter, and get rid of that. Arrow up and hit clear, enter. Now I can enter this data right here. So I'm just going to go across. Hopefully I don't make a mistake. You guys can do the same thing. Enter it in. 72, 70, 77. So you're just entering it and then hit enter. 86, enter. 34, enter. 94, enter. I'll come back. There's another 94 there. Okay, it says L121 down here in the bottom with a little equal sign on your graphing calculator. That means they want you to enter your 21st piece of data. Well, we only have 20, so we're done. We've entered everything we need. Now I'm going to move this over here, covering up this data for a minute, because I'm going to show you what we can do with it. We're going to calculate everything we need here. So we're going to go to stat again. We're going to go to calculate now. We just want one variable stats. Oops. So we're going to stay at one variable stats and hit enter. List one, that's what we want. Yep. And enter. Now the X with the little line over it up here at 73.9, that is your mean. That's your average. The average is 73.9. It looks like a weird E with the X and the X squared. That's summations. We'll get into that later. The N I would like you to look at, it's at the bottom here, it says 20. N is just the number of pieces of data you're working with, and we are working with 20 of them. what we need to do is arrow down to get the rest of our data. And there it is. That's all you need for a good box and whisker plot. Minimum X is 19, so the smallest value is 19. I put that at Q1. What am I doing? Minimum, right here, 19. Your maximum, you can see the max down there is 94 is the biggest. Median, MED, median, that's 76.5. So there's, yep, we're just taking half of that, which doesn't seem right. But Q1 is 69. That's your first quartile. That's the first 25% of your data. Median represents the 50% of your data, and your Q3 is 85.5. So 76.5 for your median. It's 76.5 because there wasn't one number in the middle, so I took the two numbers in the middle, added them together, and divided by 2. Anyway, smallest to largest, we're going to do a box and whisker plot here. It's pretty easy. 19 to 94, I guess I'll start out with 10, 20, 30, 40. You need a number line here that covers all of your data. I'm going to put a dot at the minimum. That's 19. That's right about here. You can put a 19 above it if you want. 94, right about here. We'll put a 94 above it so I know what it is. Your box is represented by your first quartile and your third quartile. 69 is right about here. You're going to put a line going up and down there. 85.5 is roughly right about there. So this first line is my Q1. I'll put 69 above it so I know what I'm talking about. You can label it if you want. And 85.5. Your median, 76.5, I would say is roughly right here. And these whiskers, you just connect them to your boxes. Now, each whisker in each box represents 25% of your data. The smallest 25% of your data is right there. Largest 25% is right there. Now, I know the first whisker is bigger than the last whisker. That just means all the data in here is a little bit more condensed. This data is more spread out. But you have the same number pieces of data in each one of those. Here's 25% of my data, and here's another 25% of my data. This whole box added up together represents 50% of your data. So if I said, what percent of my students scored less than a 76.5? Well, that's this right here. I would say 25 plus 25, or 50% scored less than 76.5. If I said who scored more or higher than a 69, well, this 25, this 25, and this 25, I'd say 75% scored higher than a 69 on the test. And that's pretty much it. You guys can work on your notes now. Peace out.